Hi everyone. So I'm going to go over this lesson one more time. It's Algebra 1 Solving Linear Inequalities Part 1. Okay, so what are inequalities? Inequalities are just what we use to compare different numbers or quantities or expressions in math. Okay? And what we do is use symbols to do them. So like greater than or equal to, less than or equal to. And if you have trouble remembering this, you can think of the face of a clock. So we have 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. And notice how all the larger numbers are on the left side. So if your inequality symbol opens up to the left, it would be greater than or equal to. And if you have an inequality symbol that opens up to your right, well, what's that sign facing? It's facing all the smaller numbers on the clock. So if it opens up to your right, you would have a less than or less than or equal to. Okay, so greater than or equal to, and then less than or equal to. All right, so let's try some examples where we compare different quantities. So here we have 5 and 7. Well, 5 is obviously less than 7, right? And if you're not sure, you can always use your number line to see which one is bigger or smaller. So we have 5 and 7, and we can see that 5 is to the left of 7, therefore 5 is going to be less than 7. And as a reminder, the number line works in the following way. It's just an ordering of all the numbers from negative infinity to positive infinity. Okay, and so you can have something like -1 and +1. So all the numbers to the right of 0 are going to be positive. All the numbers to the left of 0 is going to be negative numbers. The most important thing, though, about the number line is that the further you go to the left, the smaller your numbers are going to get. The further you go to the right, the larger your numbers are going to get. Okay, and you might be confused by this somewhat because let's say, for example, you're comparing -15 and -10. Well, we know that since -15 is to the left of -10, -15 is going to be less than -10, right? It's smaller. But you might be confused by the fact that 15 itself, in other words, the absolute value of -15, looks like it's larger than the absolute value of -10, right? 15 itself is obviously larger than 10, but it's a negative, okay? And when you're in negative number land, in other words, if you're to the left of 0, you have to reverse your thinking. The larger the numbers get towards a negative infinity, the smaller your numbers are actually getting. Okay, so let's try this example. We have -5 and -7. And on the number line, this would be, we would have -7 here and -5 over here. And since negative is to the right of -7, -5 is going to be greater than -7. Okay? How about this example? We have -10 and -20. So let's put -20 here and -10 here. Well, since 20 is to the left of -10, it's going to be less than -10. Or in other words, -10 is going to be greater than -20. Okay, so we would do that. And then 7 compared to 5. Well, 7 is obviously greater than 5, so we would have a greater than symbol. Okay. Let's do some more examples. But before we do the more examples, I want to go over strict inequalities and non-strict inequalities. Strict inequalities are greater than or less than symbols. Okay, in other words, they have to, what's on the left side has to be, so if we have that, what's on the left side has to be greater than what's on the right side. And if we have that, what's on the left side has to be less than what's on the right side. With non-strict inequalities, it's a little bit less stricter. So the non-strict inequality symbols would be this one. So greater than or equal to, and then less than or equal to. Okay, in other words, they can be equal to what's on the other side. So if we have something like 3 greater than 3, that's going to be a true statement because 3 can equal 3, right? 3 is greater than or equal to 3. If we had something like 3 less than or equal to 3, this is also a true statement because 3 is equal to 3. It can be less than or equal to 3. Okay, so just to keep in mind, strict inequalities, greater than or less than. Non-strict inequalities are greater than or equal to and less than or equal to. Okay, let's move on to interval notation. So here we have interval notation, and basically we're going to use parentheses and square brackets to express inequalities. It's just a simpler way and a more concise way to express inequalities. So strict inequalities are going to be denoted by parentheses. So if you have an expression, so let's say you have something like x is less than 3, you would use parentheses to express that. Okay, because it's a strict inequality. If you had something like x is less than or equal to 3, you would end up using brackets to do your interval notation, because less than or equal to is a non-strict inequality. One thing to remember is with infinity, both negative and positive will always be bounded by parentheses. So negative infinity and positive infinity will always be bounded by parentheses signs. Okay? Negative infinity and positive infinity are not numbers. On the number line, the strict inequalities are going to be represented as open circles, and non-strict inequalities are going to be closed circles. So again, let's say here we have a number line. Let's say we wanted all the numbers greater than 3. So greater than is what? It's a strict inequality, right? So we would do an open circle and have an arrow pointing all the way to the right, meaning all numbers greater than 3. This is different from saying, this is different from non-strict inequalities. So if we had 3 and we wanted all numbers, I meant to say greater than with the 3 and then greater than or equal to. So greater than, all numbers greater than or equal to 3, we would do closed circle. And we would point to the right. Okay, we want all numbers greater than or equal to 3, so it would include the 3. Okay, so on a number line, open circle, strict inequality, closed circle, non-strict inequality. All right, so let's do the following. Let's try the following in interval notation. So x less than 7. So what this statement is saying is we want x can represent all numbers, not just a single number, but all numbers that are less than 7. That means we can plug in a 6, we can plug in a 0, we can plug in -7, -10. It represents an infinite amount of numbers. Okay, this is an inequality statement. So on the number line, this would be drawn as, so I could put a 0 there and then a 7. And since it's a strict inequality, I would do an open circle And since it's all numbers less than 7, I would have an arrow pointing to the left, towards negative infinity. Okay? And in interval notation, this would be, we would start from the left, we would read this graph from the left and go towards the right. So all right. So in interval notation, this would be negative infinity to positive 7, open, since it's an open circle, will be parentheses. So that would be our answer. Okay, and my recommendation is to try always, when confronted with an inequality problem where you have to convert it to interval notation, is to first graph the inequality on the number line and then translate it into interval notation. Okay, so let's get some practice in. So here we have an example. It says write in interval notation, and we have x is less than or equal to 7. Well, let's draw it on the number line. So we have 0, and then we have 7. And it's a non-strict inequality. All numbers less than or equal to 7. So we would do a closed circle. And then we would point to negative infinity, because it's all numbers less than or equal to 7. And in interval notation, this would be negative infinity. Okay, start from your left, which is negative infinity, to positive 7, closed circle, so it would be a square bracket. Okay, and so that would be our answer. All right, let's try this one. X is greater than 10. And again, if you're watching this live stream as a video, like a video on demand, you could simply pause the video and try these examples on your own. So this is x is greater than 10, and in interval notation, it would look like this. We have an open circle, and it's greater than 10, so it would be all numbers greater than 10. And in interval notation, it would be 10. We would start at the 10 right here, parentheses, and include all numbers going up to infinity, positive infinity. And so that would be our answer. All right, let's try another example. It says x is greater than or equal to 10. And again, let's draw it on the number line. We have 0, we have 10. And since it's a non-strict inequality, we can use a closed circle and have it point all the way to the right. Okay, greater than or equal to 10. In interval notation, this would be square bracket, negative 10 to positive infinity. And that would be your answer. All right, another example. X is greater than or equal to negative 3. Same thing. Start with your number line. We have negative 3, and it's going to be a closed circle because it's a non-strict inequality. And it's going to be all numbers greater than 3. So we're going to draw a line going all the way to positive infinity. In interval notation, this would be negative 3, square brackets, because it's a closed circle, to positive infinity. And that would be our answer. All right, so here we have a compound inequality. With this one, anytime you see an expression that looks like this, where we have less than or equal to, it's basically talking about all numbers in between these two endpoints. And your small number always has to be on the left side, and your large number always has to be on the right. And in interval notation, this would be negative 1, parentheses, because that's a strict inequality, and then 5, square brackets, because that's a non-strict inequality. Okay? Anytime you get an expression like this compound inequality, it's always asking for the numbers in between the endpoints. Another way you could do it is to break it up into two inequality statements. So x is greater than negative 1 and x is less than or equal to 5. Okay, anytime you see a statement that looks like this, where you have two inequality signs, and they're less than or less than or equal to, it's an and statement, what's called an and statement. And then we could draw these two statements on the number line. So we have -1, and then we have 5. The first one is saying all numbers greater than -1. So we would do a circle, and we would point all the way to positive infinity. The second statement is saying x is less than or equal to 5, meaning all numbers less than or equal to 5. So close circle, and it would point left towards negative infinity. And this and is telling you one thing. It's telling you to find the intersection of these two inequalities. And what we can do is circle the intersection on the number line. So it would be that thing, okay? Because the intersection occurs where they cross. So our answer represented on the number line would look like that. In interval notation, though, it would be -1 parentheses, okay, since we have an open circle, to +5 square bracket, since we have a closed circle. And that would be your answer. And notice our two interval notations match, okay? They're saying the exact same thing, except this is a shortcut, okay? As soon as you look at it and see something like this, you would realize that it's just asking for numbers, all numbers between -1 and 5. And then you would just take care to do a parentheses for your -1 and then a square bracket for 5, okay? Let's try out another example, same type. So again, no need to break it up into two separate inequality statements using and. It's just asking for all numbers between -2 and 6, and then you just look at the signs. Both of them are non-strict inequalities, so you're going to use square brackets, meaning they include -2 and they include 6. And so that would be your answer in interval notation. Okay, now we move on to the heart of our lesson, which is algebraic inequalities. And what you're going to do is basically treat the inequality sign as if it's an equal sign. And then you're going to use all the tools that you used before to solve the inequality. In other words, you're going to use the addition property of inequality and the multiplication property of inequality. Okay, you're going to isolate x and solve for x just as you did before, except you're going to take into account the fact that we're using an inequality sign instead of an equal sign. An important detail is whenever you multiply or divide both sides of an inequality by a negative number, you must remember to flip the equality sign to its opposite. So let's say you had a statement like 3x is greater than 15. Well, -3x is greater than 15. What we want to do in this case is isolate x, okay? To do that, we divide both sides by -3. The -3's would cancel, and we're just going to be left with x. But notice that we're dividing by 3. Since we're dividing by -3, we have to learn to flip this inequality sign. So that would become a less than, and then 15 divided by -3 would be -5. So this would be our inequality. Okay, and in interval notation, it would be what? All numbers less than 5. So -infinity up to -5, but not including -5, right? This is a strict inequality. So in interval notation, our answer would look like that. Okay, you have to remember to flip your inequality sign. Okay, so let's try this example. It says solve and write your answer in interval notation. We have x plus 5 is less than 7. So to isolate x, what are we going to do? We're going to subtract 5 from both sides. That's going to leave us with x is less than 7 minus 5 is going to be 2. Okay, so there's our inequality. In interval notation, this would be what? X is less than 2, so it would be an open circle pointing all the way to -infinity. Okay, so to translate this into interval notation, it would be -infinity. In other words, you're going to start from your left side and move to the right. So we start with negative infinity, and it goes to positive 2. And it's going to be a parenthesis since we have a strict inequality, okay? Open circle. So that's our answer. Okay, let's try another one. We have x minus 11 less than 7. To isolate x, we're going to add 11 to both sides. That's going to leave us with x less than 18. On the number line, this would be, so we have 0, and somewhere over here we have 18. And it would, since x is less than 18, open circle, point all the way to negative infinity. In interval notation, this would be negative infinity to positive 18 parentheses. Why is it parentheses? Because we have an open circle. It's a strict inequality. Okay, let's try another one. Again, isolate x. So divide both sides by 3. We get x is less than 5. 15 divided by 3 is 5. On the number line, this would be an open circle, since we have a strict inequality, pointing all the way to negative infinity. Okay, x is less than 5, so it would be all numbers less than 5. In interval notation, this would be negative infinity to positive 5 and parentheses. Again, since it is a strict inequality or open circle. Okay. Let's try another one. Here we have negative 3x is less than 15. Again, let's isolate x. We're going to end up with x less than 15 divided by negative 3 is negative 5. However, I've made a mistake. Since we're dividing by negative 3, we're going to flip the inequality sign from less than to greater than. So our answer is actually x is greater than negative 5. Okay? On the number line, this would be, so we have 0 there, negative 5. It would be all numbers greater than negative 5, so I'm going to draw an open circle and point all the way to positive infinity. In interval notation, this would be negative 5. So you start with the negative 5, you start from left, parentheses, positive infinity. And that's going to be your answer in interval notation. Okay, let's try another one. We have negative 9x less than negative 27. Same deal. Divide both sides by negative 9. But since it's negative, you have to remember to flip your inequality sign. 27 divided by negative 9 is going to be negative 3. In interval notation, this would be all numbers greater than negative 3. So you're going to start with negative 3. And since it's a strict inequality, we're going to do a parentheses. And it's going to go all the way up to positive infinity. Okay? And if you wanted to see this on the number line, it would be negative 3, open circle, pointing all the way to positive infinity. Okay, last example, we have negative 1/2 times x is less than negative 7. How would we do this? Well, first thing I want to do is clear the fraction, right? Just as you did with equations, we don't like fractions and inequalities, so we want to clear the fraction by multiplying by 2. Notice that if you multiply by 2, this 2 on the denominator is going to cancel. So I'm going to multiply 2 with that term and 2 with that term. So 2 times negative 1/2 is going to give us negative x. Okay, so 2 over 1 times negative 1 over 2. The 2's cancel and we're just left with negative 1. Okay, so negative 1x less than negative 14, right? 2 times negative 7 is 14. And to get rid of this negative 1, I'm going to divide both sides by negative 1. And when I do that, I'm going to be left with positive x. And since we're dividing by negative 1, we're going to flip the inequality sign. So positive x greater than positive 14. Negative 14 divided by negative 1 is positive 14. So here's our inequality statement. And On the number line, it would be, so we have 0 and 14 somewhere along here. All numbers greater than 14, and it's a strict inequality, so it would be an open circle. We're going to point it all the way to positive infinity. So in interval notation, we would start with the 14, parentheses, and it would go all the way up to positive infinity. So parentheses and parentheses. And that would be our answer. Parentheses 14 to positive infinity. All right. So that does it for this lesson. Algebra 1, solving linear inequalities. This video will come with a homework if you're interested in doing practice problems. And next lesson will be solving linear inequalities part 2. Okay, thank you.